So once again, ladies and gentlemen, you are all welcome to the Valley of Shadows of Multivariate Data Analysis. The focus is on panel data econometrics. Econometrics is a combination of statistics, okay, and mathematics for handling economic problems. But in order to do that, you need to have a data set. Okay, normally you have a data set. And there are three main kinds of data sets that you'll be dealing in your research. Every single one of you is going to write a thesis, a research, a dissertation. And you need to know the kind of data you're going to pick. One data is called cross-sectional. We have been dealing with the cross-sectional data a number of times. In fact, that was what we did when we were doing the simple regression and multiple regression. It was all cross-sectional. A typical example of a cross-sectional data is the number of banks in a particular year. The number of banks in a particular year at a single point in time, or the number of banks over the 10 years at a single point in time. Okay. Ordering is irrelevant. You don't need to rank them. You don't need to order them. Okay. It can be cities. It can be households. It can be firms. It can be countries. It can be continents. But sometimes you can have a single observation or multiple observations at multiple time periods, okay, at multiple times. In this case, the ordering matters. You got to order them in chronological order. Okay. A typical example is you can look at inflation over the past 50 years. It's a time series data. Time series is based on the time. The time here matters. So this is where the issues of autocorrelations have to be handled. But you can have a different kind of group of observations that are changing across individuals and across time. The entities are changing across individuals and across time. This is a panel or longitudinal data. So in this case, you will have multiple banks over multiple time periods, multiple cross-sectional individuals across multiple time periods. That is a panel data. It is said to be the best of the kind of data that you should have. There are two kinds of panel data, ladies and gentlemen. The first one is a balanced panel, and the second one is an unbalanced panel. So please note, in a panel data, the individuals, the cities, the countries, the firms, the households, they are indexed by I. I means individuals. And they are also indexed by time, T. Now the I are from 1 to N. The N is the total number of samples. The T are the number of times. Each time, 1 year, 2 years, 3, up to capital T. That is the total number of time. So when we say a panel is balanced, what it means is that each cross-sectional observation, okay, appear in each time period. So everyone, so if you have 10 banks, for example, and then you have 20 years, for every year, the 10 banks are all showing, they are appearing every year up to the 20 years. That is a balanced panel. But an unbalanced panel, okay, there are 10 banks, but in 2001, there were 8. In 2015, there were 12. So they changed. You know, one bank doesn't appear all the time periods. Okay. And this is where we say the data is unbalanced. It's an unbalanced data. Now, if you are ever using a panel data, according to Baltalji, 2004, there are a lot of advantages of using this kind of data. One of them is that it increases the sample size. Okay, there is a larger number of observations that will increase the sample size. It will increase the degrees of freedom. And so it will reduce this multicollinearity. It will also reduce what we call the curse of dimensionality. Let me explain to you what I mean by the curse of dimensionality. Let's say you have a variable x1, x2, x3, x4, x4, x5, and then x6. You have all of these. You have data on all of them. Of course, you have Y, the dependent variable. I'm speaking in terms of regression. But the number of observations, okay, we have how many companies? Okay, we have company 1, we have company 2, we have company 3, and we have company 4. Okay, so how many variables do we have? Who can type it for me? How many variables do we have here? How many variables? How many variables? Type, say some, you won't die. How many variables are there? 6 variables. 6 variables. You see, because somebody wasn't paying attention, the person said 24 variables. There are 6 variables. How many samples do we have? How many samples do we have? How many samples do you have? Okay, somebody is still saying 6. How many samples do you have? We have 4 samples. Very good, Comfort. Very good, Eugene. Very good, Stephen. Very good, Atiku. Very good, Charlotte. There are 4 samples. Now that means that the number of observations, the dimensions are more. So 4 samples are going to carry the observation. It will be too much for them. Okay, usually the number of samples must be, sometimes when we talk about larger samples, there must be more than 30. Okay, larger samples must be more than 30 or 30 or more. And now we have 4. Now the problem you're going to have is that you're going to have insignificant p-values eventually. It's going to cause a lot of problems. You're going to have issues of multicollinearity. You remember all the assumptions of regression? You're going to have more of those problems there. So what do? Augment, increase the size of the data. And this is where panel data comes in. Panel data is able to help you to increase the size. So as you collect these 4 firms, okay, 4 firms, so you collect these 4 firms in the first year. Okay. Then you collect the same 4 firms in the second year, the same 4 firms in the third year, the same 4 firms in the fourth year, same 4 firms in the fifth year. Now, because there are many of these 4 firms, now we have 20 firms because we have now added more years. Now, time, paneling is helping you to increase the sample size, and that will help to deal with the problem. So it's very important to understand that when you have panel data, one of the advantages is that you are able to raise the efficiency of the data set. So the whole issue about best linear unbiased estimator, okay, you're able to achieve that. But again, there's a caution there. More data doesn't mean that more information. Because you can, what is going to happen is that as you add more data, every time you are adding more data, you're also adding more possible problems. You see, being friends with people is fantastic. You can increase your network of people, and your network defines your net worth. Okay, that's fantastic. Okay, because you know a lot of people, so whatever you bring into the world, a lot of people know you, so they are more likely to join you. Great. But then the thing is that each person is coming with his own demons. There are still demonic characters that are coming in the process. And so there's a lot of heterogeneity. There's a lot of diversity of people, differences. And these differences will come in, and it can because most of the time you want homogeneity. You want cohesion. You want everything to be homogenized. And so the fact that you are adding more data means that they could come with their own errors. Randomized errors will be popping in the process. And that is one issue to deal with when it comes to panel. But what we know is that panel data gives you more information, because you are going to address questions that cross-sectional and time series data couldn't address. What? For example, you can identify the impact of actions, the impact of treatment, the impact of controls, the dynamic relationship, policies. You're able to handle all of this because of panel. You can control for the unobserved heterogeneity or omitted variables. For example, let's talk about a human being. A human being who is able to get more salary because of his education. But education is measured by the number of years of schooling. But that person may have some innate ability, inside ability. But this innate ability will not be much more paramount, but will be paramount over time. So as time goes on, the person's character, the things you don't see, will become apparent. And so you are able to control for those unobserved heterogeneity in the data set, and panel this fantastically with that. With panel data, you can generate more accurate prediction. You're able to predict with confidence. Okay? You can make inferences. You can handle issues of non-stationarity, measurement error, dynamic panel data models, all of them are handled. Now look at this data set. This is a panel data. How do we know? Well, look at the data very carefully. You notice something. You notice that when you look at this section, okay, you have year 1980, 1981, 1982, all the way up to 1980. That is the first observation. Okay, do you see that? That's the first observation. Okay, the observation of firms. But then when you look at it, it starts again for the second observation. I mean, second company. Okay, that company also from 1980 all the way up to what? 1990. All the way up to 1990. This third one also starts from 1980 all the way up to what? 1990. So every one of them has got 10 years of data. GDP is evident in every section, and consumption and price are also evident in every section. This is a panel data. Let me ask you a question. How many observations are here? This panel data, how many observations are here? How many observations? You can type it there for me. How many observations are evident here? 33, exactly. 33, which means that the sample in this contest, the number of firms are how many? 3 firms. Or in this case, if it is a country, the number of countries are 3 countries. And the time period is 11. And that is why we have 33. That's a panel. Balanced. But look at this second one. This second one, you can see that this observation, it has some of the variables not available. Okay. It has some of the observation in some of the years not available. It has some of the observations in some of the years not available. So you can see that, yes, it's panel. There's also got the same 30 observations, but some of the observations are missing data values. And so it doesn't make it balanced. It makes it what? Unbalanced panel. Unbalanced panel. Okay. So normally for some models, you have to remove the observations that do not have some of their variables, non-valuable items. You have to remove them. So you have to delete 1980, 80, 81, 82 here, and then you have to delete 1989, 90 here. You have to delete. Okay, for some models can deal with unbalanced panel. So you can still run the data and then use the unbalanced panel to that. There's no problem. We'll do it. But most data sets are unbalanced, generally speaking, than balanced. Okay, now, before we discuss panel econometrics, I want us to refresh our mind with the cross-sectional data we did. Cross-sectional data, watch this. The dependent variable is y. We know this already, cross-section. And then we said that we have a constant, okay, the constant. We have the constant or the intercept, which is the alpha. And then we have multiple independent variables. That's what you see here. We have taken the prime of them because this is a matrix. And each of the multiple independent variables has a beta parameter. And then there is an error term. The individual observations are I from 1 to n. Okay? So this is a typical cross-sectional model that we know of. A panel model, now watch it, the cross-sectional model, there is an I attached to the explanatory variables. There's an I attached to the random noise. There's an I attached to the dependent variable. However, for a time series, there are no I. For time series, there is rather a T because it's time dependent. There's rather a T, okay? There's rather a T. So it is changing. What this means is that cross-sectional models are changing across individuals, across individuals. So you can have a bank this year, bank this year, another bank this year, another bank this year, all of them this year, but the banks are different. The individuals are different. However, in a time series, you can have the same inflation. Okay, the same inflation for Ghana, the same inflation for Ghana, but over time, the inflation is changing. It's changing across time, but it's not changing across individuals because you are dealing with only Ghana. And that is a time series. Now, what do you think the panel will be? It will be adding both the time and then the individuals, adding both the time and the individuals. Now, let's look at the assumptions of regression. Let's refresh our mind with assumptions of regression in the world of panel. I know you remember the assumptions of regression in the world of cross-section. Okay. And I'm going to ask you some of them, some of the assumptions. You have to understand these assumptions because they are somewhere you will face. The first assumption is called exogeneity. Exogeneity. Okay. Sometimes we call it weak exogeneity. What is that? Well, this is for cross-sectional actually. Okay. This assumption is for cross-sectional. Okay. But the key point of exogeneity is this: that's the expected value of the error term is zero. Sometimes we call it a zero mean. Okay, the expected value is zero mean error. So sometimes we say that the error term is normally distributed with a zero mean and a constant variance. You remember that? Now that expected value, so we expect that over time, okay, we expect that over time, or even across individuals, the error term is zero. The error term is zero. That is weak exogeneity. Now, this is given the independent variables. Okay. Now, without this assumption, okay, what it means is that the beta parameter will be inconsistent. It will be unbiased, but it will be inconsistent as well. Okay. And please, if you want to check unbiasedness, check the other videos I have on the page. Unbiased. Now, this assumption, if it is not there, then there's endogeneity. Endogeneity happens when the error term is correlated with the independent variables. Note it. When the error term is correlated with the independent variables, we have endogeneity. Now, let me remind you something you know. Okay, I want to take you a little bit. I know somebody is probably sitting there and they say, "What's all this Hebrew? What is all this Hebrew?" Please, it's not Hebrew, it's English. Okay. Let me remind you. Do you remember multicollinearity? Do you remember? Who can explain what multicollinearity is? Do you remember multicollinearity? Who can raise a hand and tell us what is multicollinearity? Multicollinearity. Okay. Let me see whether Isa is there. Multicollinearity. Isa, please, I want to be giving. Let me make you a. Isa, are you there? Multicollinearity. Isa. Okay. Priscilla Anchi. What is multicollinearity?
Doc, I think multicollinearity is where the independent variables can impact each other. They are correlated.
Good. They are highly correlated. 2 months. Now, let me tell you something. Then when the independent variable x1 and x2 are highly correlated, when they are highly correlated, okay, it means that we have a multicollinearity. That's what we said the last time, that they are so correlated that it becomes difficult to disentangle the partial effect of one from the other on the dependent variable. Okay, that is multicollinearity. Now, when they are correlated, we didn't talk about the error term, whether that is also correlated. So when we were saying that the independent variables are correlated, we were assuming that the error term is not there. We're assuming that the error term is not there. Now, what if the independent variable is correlated with the error term as well? Then we have a problem of endogeneity. Okay, so that is a huge problem in dynamic panels. Another assumption that must be there, by the way, when we say assumptions are certain things that got to be there for certain things to work. Okay. Certain things that got to be there for certain things to work. Okay, Kofi Bekwe, you seem to have a question. Kofi, you have a question? Okay, I think Kofi is not having any more questions. Let's go to homogeneity or homoscedasticity. We said it before, and it's a similar thing here. The variance of the error has to be constant. Okay. Without homoscedasticity, the beta parameter will be inefficient. That's serious. It will be inefficient. Okay. And efficiency is important. Okay. In other words, you must have trust in it. Homoscedasticity is well known in cross-sectional data that we did. The next thing is that there must be no autocorrelation, but here we speak more of serial correlation. Okay. In other words, you see, autocorrelation that we spoke about was the UI being correlated with its past. Okay. So UI and then UJ. Okay. But the thing about more serial correlation is that you are not just correlated with your individual another observation, but you are also correlated over time with yourself, because now time has been added. There's time in panel data. So you can see that the error is correlated with another error, but the error is correlated with itself in another year, because that other year makes the current error, different from the other year. So that is an assumption. Okay. We expect exogeneity, we expect homoscedasticity, and there should be no serial correlation of the errors. The next assumption is that there should be no endogeneity. There should be no endogeneity. Okay. In other words, I've said it already, the covariation between the error and the independent variable must be zero. This is what is known as the independence. Independence, zero covariation. And then, of course, there must be no perfect multicollinearity. Okay. There must be no specification bias. Of course, we need linearity in there. In a panel data, we talk about strict exogeneity. Okay. In other words, the expected value of the error term, okay, which changes across individuals and across time, should be zero. Okay. It should be zero. Given, of course, an independent variable, it doesn't matter which one it is, it should be zero. Now, when there's a problem with heteroscedasticity and autocorrelation, you use a model known as feasible GLS or GLS. Notice, this is important. Okay, you use feasible GLS or GLS. Okay, but when there's a problem with endogeneity, you resort to instrumental variable regressions, okay, some of which are two-stage least squares and generalized method of moments. Don't worry. If you don't get all of these things, don't worry. One thing academicians should do is that they will make you know that you don't know and make themselves know that they know. So don't worry. Let me give you the general panel model. Okay, this is a general panel model that you see here at the top. Everything is IT. In other words, they are changing across individuals and across time. But then the random noise, unobserved heterogeneity, okay, the unobservables are composed, is made up of UI, which we call the individual specific effect, is made up of lambda t, which is called time specific dummies, and finally is made up of the usual random noise. Okay. For those of you who do efficiency and productivity analysis, and you talk about second stage variable, the dependent variable becomes efficiency score, or it can be return on asset or return on equity. Then in a proper panel model, the constant term is not there. So you can see that the alpha has been removed. Okay. And so you will have the Z variable, we call it environmental variable. These are the independent variables. And then you have the error term in there, the error term, which is a composed error term made up of 4 items. So all of these have been well interpreted and well explained in the model. So first, note that the independent variable is a vector of observed or explanatory variables. We call it environmental variables, okay? The variables of interest. It does not include the observations and the constant. The UIT, the error term, we've said that it is identically independent and identically distributed with a zero mean and a constant variance. That's the error term. It's composed. It's composed. And we'll look at each of the components. Okay, but before that, let me share something with you about the explanatory variables. And again, I have some questions here for you. What is the difference between a varying regressor and a time invariant regressor? What is the difference between a varying regressor? Now, if you look at the first x, it is equal to xit. Okay, it is equal to xit. Yes, Kofi, go ahead.
Yeah, the variant regressor is basically regressors that change across time.
Not only across time, but what? It changes across time and across individuals. It's both across time and across individuals. So note that. That is why you see the IT attached to them. Okay, a varying regressor, a changing regressor. Okay, an invariant regressor is one that is not changing across. But if it is time invariant, then it means that it does not change with time. The word is invariant. If it is time invariant, it is not changing across time. But you can see that it is only changing across individuals. So the time is considered to be fixed. Time invariant. It varies across individuals. So give me an example. Example could be gender. Gender does not change across time. You don't just change your gender just like that every year. Every year you're changing it. It doesn't change. Really, what do you call it? Race. It doesn't change across time. So these ones are called time invariant regressors, or time constant regressors. Time constant regressor. And then we have the individual invariant regressor. That one is the one that is changing across time, but it's not changing across individuals. Changing across time, not changing across individuals. Like macroeconomic factors. They are mostly changing across time. They are not changing across individuals. Who is not clear at each point? Management style. Okay, that's also true for the time invariant. Okay, so note these kind of words because they will be using themselves throughout. Now let's go to the element of the error term. The first element of the error term we said is the UI. The UI. What does that mean? Well, it is an unobserved, time constant, time invariant, individual specific factor. So it is only changing across time. Okay, we call it unobserved heterogeneity or nuisance. It has no time index. If you look at it, it has only individual index. I. It captures the characteristics of the I that are not picked. They are not picked at all. A person can have a special ability or skills that can make that person perform better than another person. That is what is known as, unobserved heterogeneity. Unobserved heterogeneity. Unobserved. For example, you can have a certain company doing well. Okay? You see it in the return on assets, return on equity, but there's an embedded culture that is there. You don't see that. That must be captured. And it is called unobserved heterogeneity. Okay? You can have religion, gender, race, all of these things, okay? That may be defining the way the person is behaving, the way he's behaving. Now, the unobserved heterogeneity can be a dummy variable for each of the observations. Okay, it can be a dummy variable, and you see it. In fact, the religion I gave you is even a dummy. Gender is a dummy variable. Race is also a dummy variable. And so all of them will be working within those parameters. Okay. Now let's go to the next item in the unobserved error term, and that is symmetric time trend. It's a lambda t. It's a lambda t. Please, in case you've forgotten, we are talking about this whole elements here. Okay, the elements in the lambda t. Okay, we have spoken about the UI, we have spoken about the lambda t, and we are going to talk about this after the lambda t. Note this element before you see it somewhere. What is the lambda t? Well, as you can see, we talked about it as time trend. Time trend. Time trend. What is a time trend? Well, there are certain things which are sort of time, they are changing dummies, and they are normally good for controlling technological dynamics. For example, there's a regulation and that regulation is what is going to cause things to change. For example, minimum capital requirement regulation. Minimum capital requirement regulation. Macroeconomic events like inflation, like exchange rates, interest rates. Okay, all of these things can affect the dependent variable in a way that sometimes you might not detect. So if they are there, you capture them. But this is normally so when you are dealing with cross-country studies. That is when macroeconomic events become paramount, like you are doing African cross-country studies. Okay. So that is it. Or you can include them as a time dummy. So in this last one year, they can be dummy variables. So you can have, for each year, you create a dummy for it, for each year. So you are either the year 2001 or any other thing otherwise. The year 2001, you represent it by 1, every other thing otherwise, and then it keeps on going. So in short, the symmetric time trend can be macroeconomic factors, or they can be things related to time dummies. All right. The last one is idiosyncratic error, the random error. But there's a lot of questions I've set on this in this past few minutes. Yeah, idiosyncratic. Now, the most important thing about all of this is that it is the assumptions we make about them. The assumptions we make about the errors, the exogeneity of the regressors, all of these have led to what is known as multiple panel data model. There are so many panel data models. Sometimes you ask yourself, which one is which? We are going to look at a few of them. But this is a specific example of a panel data published by myself in 2018, okay, about a model that I was actually working on. Okay. Now, watch not just the name of the model, but watch whether it is time, is changing across individuals or across time. So look at the first one. The first one is changing across individuals and across time. This is called productivity index. Productivity index. So we calculate a certain productivity, and this index, we believe that it is affected by other factors. Okay. So the productivity index, so the productivity is dependent, okay, or it's a function of the following. The first one is, this is an insurance company, by the way. So we created a situation where we say that it is dependent on whether the insurance company is life or non-life. Whether the insurance company is life or non-life. Now, who can tell me the problem here? Okay, whether the insurance company is life or non-life. There's something problematic about the model. Who can tell me? The productivity is a function of whether the insurance company is life or non-life? You can tell me what is the problem with that modeling, because it was deliberate. Okay. Well, you can see, let me see whether somebody signed it up. You will notice that life or non-life, it's changing across individuals. So when you have an insurance company, it's either a life company or non-life. It's not changing across time. So why do you bring this T here? So this T shouldn't have been, because it's changing across time. Now the next variable is a credit risks. Okay, so that is credit risk. Credit risk is what? Is a continuous variable. So that one is changing across time and across individuals. So that's correct. It's changing across I and then across T. The next thing is, what is the next thing? The leverage. Leverage is a numerical variable. It's changing across time and across individual. Leverage. The next variable is the log of the total asset. Total asset is changing across time and across individuals. The next one is GDP. GDP doesn't change, because we are talking about Ghana. GDP doesn't change across individuals because we are dealing with only one country, but it's changing across time alone. So that's why you see only T. The way you formulate the model is important, though, very important. The next one is inflation. And you can see that inflation is for only Ghana, only one country. So it's changing across only individuals. Across time. It's not changing across individuals. And then the next one is pure technical efficiency. It's the numerical value. It's changing across time and across individuals. Okay. And then another scale efficiency, which is numerical value. That is also changing across time and then across individuals. And regulation. The regulation is changing across time. So you see only T is there across time. And then the error term. Okay, the three components of the error term. The first one you are seeing here is a symmetric time dummies. Then you have the unobserved heterogeneity. We call it the individual specific factors. Okay. In fact, it could have been any of the independent variables. And then the last one is the error term itself. So ladies and gentlemen, this is a typical example of a formulated panel data model. Panel data model. Wow. Wow. So if you are formulating the model, you got to be right. Okay. You got to be right. Okay. So we can have different panel data models, and we'll look at them, okay, in the course of this. Okay. We are going to implement the panel data model that we have using the wage pan data. I think I've given you all the wage pan data. If you have the wage pan data, type yes. If you don't have the wage pan data, type no. If you have the wage pan data, type yes. If you don't have the wage pan data, type no. If you have it, type yes. If you don't have it, opele. If you have it, type yes. Ope. Ope, type yes. If you don't have it, type no. The wage pan data. The wage pan data. Yes or no? Yes. Almost all of you are saying yes. So it means that you all have it. Okay. I know somebody is sitting down. Oh, I won't say it. When they say it, it will survive. Okay. Well, it's being recorded, so say it. It will help you. All right. So it's very important to recognize this data. I want to give you some feel of the data. Look at the data set very carefully. Look at it carefully. Look at it with joy. This is a panel data, and it is in the long form. Okay. You can see that one line for every individual, as you can see, ID. Okay. ID are the names of the individual. And you have the year. So if you look at individual with ID number 13, that individual has 1 to 8 observations, and they are according to the number of years. Okay. This is a real data set. We are going to use it to illustrate the different models that will be discussed. Wage pan data. Let's try to give a title to this, okay, so that you can appreciate it the more. Okay, so let's give it a title. Let's give it a title. Wage pan, wage pan, wage pan. I'm taking you back to the slides. Wage pan. This is the title. Actually, this data is in a book by Vella and Viebeck. Okay, Vella and Viebeck. These guys in 1999, they analyzed this data. They took the data from National Longitudinal Survey, like you might call it National Service. Okay, National Service student, that's what I mean, National Service. Okay, and the data was from 1980 to 87. So that's a 8 years data set. The sample number was 545 full-time workers. They are young men, and young men. In those days, young men. What is the title that we want to give? Okay, the title is, whose wages do unions raise? Listen carefully, because this is a very important thing. When you combine yourself or when you join a union, whose wages do unions raise? A dynamic model of unionism and wage rate determination for young men. Why a title? Why a title? Okay, now because the number of young males are 545 and you have 8 years observation, sorry, 8-year panel, how many observations are we looking at? How many observations? How many observations are we looking at here? 4,360, Emmanuel Connie, that's excellent, okay? You multiply the number of observations, the number of years by the number of employees. That is what it is. Get an idea of the content. Let me just go back. So what I was saying is that they are youth, they are young, they all started working from 1980. They are between 17 years and 23 years, okay? And the average experience is 3 years. Now, experience in the Excel will be represented as experience computed as age minus 6 years of schooling. So let me take you to the data set so that I can fill it. Okay. If you look at the data, there is a variable called expect. Expect means experience. So you can see that some of the experiences are what? You have 1 year experience, 2 years experience, 5 years, and you can see the experience is actually increasing according to your time of working. Okay, so 8 years, but it's not everybody who started with 1 year experience. If you look at the second guy, look at the second guy. If you look at the second guy here, okay, 17, the person with number 17 ID. His experience, by the time he started in 1980, okay, he already had what, 4 years of experience. 4 years of experience. So it starts from there, and then he started increasing his experience. Okay. So that is an important thing to note. A very important thing to note. Experience is there. Another thing is union. Union. Okay, let me just go up here. Okay, you can see union is there. So this is 0 whether the person doesn't belong to a union, but it is 1 if the person belongs to a union. Okay. So if a person belongs to a union, it is given a dummy of 1. But if it doesn't belong to a union, it is not given anything. Okay, it's not given anything. Okay, so for those of you who said I wasn't recording, be rest assured the recording has been going on. All right. The next thing, as you can see, is whether these people are married. Remember, they are between the ages of 17 and 23. That doesn't mean that they are not married. They are married. Some of them are married. Some of them want to taste the waters of adulthood. They want to venture where angels fear to tread. So you can see that under married, you have no, 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 no for the first guy, because the guy was almost like 17 by the time he joined. Okay. But some people, when you go, you see yes, 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 yes. Okay. For example, if you look at this guy, at the time of joining, he's already had 4 years of experience. So the guy is a grown-up. He knows life. He understands life. Okay. And so he's married. So that section there is showing that some are married, others are not married. Another thing to watch is ethnicity. Okay. The ethnic background of the person. So this ethnic background, they have 3 of them. Whether you are a Black person, whether you are Hispanic, or you are other. So when you go, you see other, but when you go down, you'll also see the other kind of, so you see other is quite a lot, but Black has come. Black has come. So it means that this person is Black. And then other keeps coming, other keeps coming, other keeps coming. And as you keep going and going and going and going and going and going, okay, you have a lot of other, but Hispanic is down there. Remember, this is a lot of data. This is a Black has come again, and then on and on. You can't go through all of them, but the most important thing to note is that this is a dummy variable. This is a dummy variable. All right. Now, another thing is, there are several other things. For example, disability of the person, whether the person is disabled, whether the person is in a rural or urban, which part of the region is the person, okay? Which part of the region is the person. And then you also see wage. That is the salary of the person. This is $3.31, the first person, okay? $3.31 wage. So the nominal wage is not that important. And then the sector the person belongs to, okay? And then the education, how many years of schooling has a person had? And then the log of the wage, L wage is the log of the wage. Then the experience we had before, you believe that when a person is increasing his experience, it now rises, gets to a point and falls. So you have a column called experience square. Experience square, okay? You have that there. And then you have the dummies, okay? All the dummies. So 1981 dummy, it means that everywhere there is no 81, it will be 0. But wherever the person is in 81, it will be 1. So you can see that that's why in the diagonal section, okay, the diagonal section is exhibiting that 81 multiple times. So you can see the 81, 81, 81, 20, okay? As you keep going, your 81 will be 0 or 1. Okay. Any question at all on that before we proceed? So now let's look at the research questions that we want to ask. Research questions. Question number 1. Research questions. Question number 1. Has the return to education changed over time? Which variable will be checking that? Has the return to education changed over time? Which variable are we going to use to answer that? You can answer. Has the return to education changed over time? Which variable are we going to use to answer that question? Has a return to education changed? Okay, very good. Okay, log of wage. So we'll look at the wage. We look at the wage. The wage will tell us, okay, whether there has been a return to education. Okay. The second question is, what is the impact of unions on wages? In other words, does belonging to a union make you increase your wage? Those of you who are working, you know that belonging to a union might help. Okay. So that's a question. How does this vary by worker characteristics? Okay. So how do these workers actually behave? What are the key forms of worker heterogeneity generating the indigeneity of the union status? So what this means is that, exactly, thank you, Isaac, like you talk. Okay. Worker heterogeneity means that a worker might have some special difference of of skills that another will not have. And that can bring about endogeneity, because endogeneity occurs when the independent variable is highly correlated with one of the independent variable is highly correlated with the regressors. Okay, that's endogeneity. And so it's important to be able to check that. What form of economic sorting behavior in terms of union and non-union employment are the data consistent? What kind of economic sorting behavior? So you can see all of these questions. A person can ask most of these questions. Now, some of your colleagues just joined and then they left. Tell them they should join back. It will help them. They will reap a positive outcome than negative. All right. So let's check some few things. Which variables are not constant? Which variables are not constant? Well, if we check experience, it is not constant. And if it's not constant, we call it varying variables. Now, how can experience not be constant? Well, the thing is that experience is increasing by 1 year over time. Experience is increasing by 1 year over time. So every one of us is increasing its experience. So what then? It doesn't make your experience, special than another person's experience, because if we are all growing at the same experience, then it doesn't make. So that is presumably constant. Okay. Oh, sorry. I'm talking about that is presumably non-constant. So non-constant means they are changing. Oh, so experience is changing. But later on, you go and see that experience will be increasing. It will be increasing by 1 year. Okay. So every year, a child's experience go up. But later on, you come to realize that because everybody's own is experience, we will later make experience fixed, not varying. Marital status is constant because the children, they are between 17 and 23 years. And over the period of growing and going through this, they will marry. They will marry. So their marital statuses will change, but majority of them will change their marital status. And union. A person can be not a union member, but over time, the person can become a union member. So for this very variable, we are going to consider those variables as non-constant. But there are other variables that are fixed, they are constant. They don't change. And once again, you see now I bring education there. I'll talk about why each one is so. First is race. Race, you and I should know that race is constant. It doesn't change over time. You are a Hispanic. If you are Hispanic, you remain a Hispanic, okay, for life. If you are Black, you remain a Black, for life. Okay, so don't change the race. And the next one is education. Now we said that education will be increasing over time, over a 5 or more period. For example, every 5 years, it's possible that these people will go to school again. Okay, so we are going to consider education as fixed. Okay, even though it can rise over 5 years, okay, it is generally considered as fixed because once they enter the job market, the idea is that they are not going to go to school again. But we can interact education with a year dummy to test if returns to education was constant over the period. That is one way you can test. Gender would have been part of the constant variables if only it was here, but we have only men. And so we can now conclude that the few that are what it says, they are what it is. Excellent. Morgan, a comfort, I think your point is well noted. Now, we are going to take the logarithm of some of the variables. And this question I've asked before. Okay. Why do you have to take the logarithm of some variables? Okay. Let me give you an example. Wage. If you can remember, you remember that wage had a log. Okay. Wage, they had a log. So one thing is that wages was logged. If you check carefully, wages was logged. And why was it logged? Because there are some variables, if you don't log them, they will not make sense. Why? Because they are measured in nominal terms. Okay. But such variables will be increasing because of inflation. So salaries may be increasing because of inflation. And so we have to correct for inflation by deflating the 1987 wages and bringing it into 1981 time value. And we use the price deflator for that. Okay. The deflation factor for 1987 wages is the same for all individuals. If you look at 1987, that'll be. So we sometimes because of that, we can just use the nominal log wage. So we take the nominal wage or go and take the real wage if you have the values for that. So taking the log of the value reduces inflation. That's all. The difference will be simply absorbed in the intercept. So the logarithm converts the variables into percentages. So when you are actually interpreting the values, you have to deal with percentages than dealing with non-percentage values. I think that you all understand this matter of logarithm. Please, if you don't understand, you type a question or you raise your hand, okay? It will help. All right, so learn why some variables are logged. I will ask you this. Learn why some variables are logged. Second, learn why some variables are squared. And I have a link here. I want you to go and watch the link. Okay. You take the square of a variable. You remember experience was squared. Why? Why do you square experience? Well, the thing is that there are some variables that rise. So when you square a variable, what you are saying is that it's quadratic in behavior. Okay. It is no longer showing linearity. It is showing non-linearity, polynomials. So as an example, they'll be showing non-linearity. Typical quadratic variables. Okay. Why do we take the square? Because you believe that experience rises, gets to a point is false. Take example of Ronaldo. The Ronaldo, when he was with Man United and early Real Madrid, is not the same Ronaldo that we probably know today. No, it's not. Because over time, the person's experience will rise and fall. Where is Tony Yeboah? Where is Abedi Pele? Okay. You remember the days of Gu Johnson, the days of, Rooney. So experience rises and rises and rises and rises, and eventually what? It falls. And so when you believe, of course, you have to believe it based on the literature. When you believe that some variables, they rise and it gets to a point they fall, then such variable, you have to take their squares in addition to incorporating the variables in there. Okay. And you can test for whether a variable is exhibiting linearity or not. Okay. And you can use this link. Okay. You can use that link to be able to check whether a particular variable is linear. But you see, if you don't take it, you'll be adding a bunch of squares, Everybody, let's square it. No, be careful. Don't just square things by heart. Okay. You have to make sure that if it is exhibiting that test. Okay. And the test may make the, if you have such too many extraneous variables, you can produce a lot of insignificant results. So it's very important. Anytime you are squaring a variable, that variable must have theoretical backing. Let's take, for example, the total asset of a company. The asset will grow and grow and grow and grow. But it is believed that sometimes when companies grow too big, you cannot monitor them. You cannot monitor the people, so people begin to shirk. People begin to feel lazy and pass over jobs to other people. So many employees, if you look at the ministries, the government sector, so many choked. The size is big. Okay? The asset is used to as a measure of size. The size is so big, and that's why there's a lot of inefficiencies in the ministries, because there's so much size. So it is believed that size is good, but it gets to a point, it begins to reduce productivity. Okay. So it's very, very good to think about the independent variable to be sure. that it is exhibiting such situation. If not, okay, then you may have to use nonlinear models. Okay, if there's a lot of variables which are exhibiting, nonlinearity, then you have to use nonlinear models instead of a linear panel model. The final thing to note is why you have to interact some variables. If you haven't done this before, one day your supervisor will tell you to do it. That's you should interact inflation and another variable. Interacting them simply means multiplying the two variables and creating a new variable. So let's assume that two predictor variables. Let me just use this exercise. You have two predictor variables, okay? One variable is x1, another variable is x2. But you believe that x1 and x2, they support each other to affect the dependent variable. Okay, I'll give you an example, okay, where you believe that a particular variable is a capital structure of a firm is interacting with diversification or ownership for it to actually better. So capital structure on its own can affect performance. Diversification or ownership can also affect performance of a company. But when you now interact the two, when you multiply the two, you will see that probably their impact together, their combined forces, not their individual forces, but their combined forces can affect. So in this case, you could create another variable, which you call x1, x2 variable. And this one will be a multiplication of the others. That is when interaction term comes in. Okay. So the variables, you believe that they are not additive in behavior, they are interactive, multiplicative. But be careful, once again, not to just interact anybody by heart. Okay. Especially when there are a lot of independent variables and you are interacting, everybody interacting. You're going to have so many other variables. Imagine you have 10 variables, interacting every one of them. So you interact the first variable and the 10th variable. You interact the second variable and the 9th variable. You're going to have more variables in addition to this very own variable. It's very, very important to recognize that. And you don't let that affect anything else in that regard. Ask your question with a louder sound.
My question is, if you create the interaction variable and you are trying to find their impact on the dependent variable, do you now still include the individual variables in the model, or you just
yes, you don't remove. You keep them. You keep them.
Oh, okay.
You keep them. If you are interacting, you still keep them. All right. So that is it. Most variables that we use to interact other variables are dummy. Okay, so one will be a dummy, the other will be a continuous variable. And then you multiply the two together. Yeah. So that is it. That is how, okay, these interactive variables can help in that regard. All right. So there are some few key points that I want you to note when we come to running the model. We are not running it today. The first one is that if we ever use a fixed effect model or phase difference model, you may not fully understand this, but when we come there, you will know. If we are using them, fixed effect means that some variables that are fixed must not be included. So variables that are fixed, like race, education, experience, okay, will not be included in a fixed effect model. You will later learn why. The reason is because many factors may not be constant, like education, like they cannot be constant, but they might roughly be constant over a year. So even though education is rising deterministically. In other words, every year we are all having the same 1 year experience anyway. But such variables can be interacted with a dummy variable in order to test if the return to, in this case, education was constant over time. And later on, you will learn about a random effect, okay? And you see that for that one, all the variables are added. All the variables, whether it is a fixed constant or it is varying, all of them are added. But in a fixed effect, only the varying variables are included. Okay, I don't want to start you with a general panel model today. what I'm going to do is that I will start with a general panel model next time we meet, where we now look at the mathematics of the models. That's when we start learning the real mathematics of the model. And then we'll use the wage span data to model each model. That's an interesting word. Okay, you're going to be modeling each model. That way we are better able to understand everything.